Alright, so I like to just take a little sidestep from just pure organic chemistry, and I would like to take a look at biological oxidations. So biochem is super awesome. It's really fun. If you get a chance to take it, you definitely should take it. Even if you're just a chem major, it's a fun class. So I want to talk about the action of NAD plus / NADH. So let's first take a look over here at NAD plus. So this is the structure. You don't need to memorize the structure or anything like that. Just want to show you what happens here. So in the first step with this NAD plus can accept a hydride. And gaining bonds to hydrogen means that we're being reduced. So electron flow is the following, right? Comes up to this position, so on and so forth. So that H that's right here is one of these guys, okay? And now that is your reduced form of NAD plus. Now here it says, this is a weird notation, but it's minus H plus. So sometimes you'll see it written that way in biochem, and other times you see an arrow that comes up like this, and an H minus being lost there. So you've lost an H. Okay, that means the same thing. So here, that means that we are being oxidized. So NAD plus going to NADH going to NAD plus again is like a biological source of NABH4 or LAH, right? So I want to talk about what are some neat reactions that these are involved in here. So let's look at ethanol metabolism. So ethanol metabolism it describes the process of taking ethanol and changing it into other things. So here you have ethanol. So this is a primary alcohol. So with NAD plus present, it needs that, and an enzyme called alcohol dehydrogenase. Those two things together, that's what the ADH stands for. Those two things together make this compound here. And this is called acetaldehyde. So this is toxic and is partially responsible for the feeling of hangovers and stuff like that. Well, so alcohol dehydrogenase worked on alcohol. Aldehyde, ALDH, works on aldehydes. So again, it takes another NAD plus, makes it NADH, H plus, and then here we get acetic acid. And acetic acid is excreted through the urine. So the other thing I wanted to point out here, and I'm going to zoom in so I can fit it in. I didn't give myself a whole bunch of space here. So I want to talk about some fates of acetic acid. So it can go out through your urine. The other thing that can happen is through, and we'll just demonstrate this by drawing a bunch of arrows here, and let's make a note. There's many steps here, is we can make this compound CH3, C, double bond O, and then O, COA. So the name of this is acetyl coenzyme A. And the fate of this depends upon your metabolic needs. So we can come over here, and if we need energy, then it goes into the citric acid cycle or the tricarboxylic acid cycle. So this is if we need energy. If you're just sitting around and you don't need energy, then you go into fatty acid synthesis. Oh, this is why, just coincidentally, a lot of fatty acids are composed of even number of carbons because they're built up from that molecule. Okay, so interesting little side note there. So then let's go back and let's talk about this. What happens if you consume methanol? So methanol, and I can zoom back out here, so give me a second, but methanol is an alcohol also. It's a primary alcohol, right? So again, we have another primary alcohol. And primary alcohols are going to react with that alcohol dehydrogenase. Except now, what it does is it gets oxidized to form formaldehyde. And formaldehyde's not good. That's what we use to preserve, right, dead tissue. This can attack the optic nerve and can render a person blind. So, years ago, people used to keep methanol in their sheds and stuff like that, and occasionally kids, for example, would get in and they would drink the methanol, and if you just didn't do anything about it, it had the unfortunate side effect of causing eye damage, perhaps blindness. Now, NAD plus and NADH can still provide assistance to ALDH to make formic acid. Okay, so it turns out that there's a treatment for this. And by the way, formic acid too is not great. It turns into basically formate, which is a cytochrome C oxidase inhibitor. But the important thing to point out here is this, is that when you consume the methanol, you end up making formaldehyde. And there's a treatment for this. We'll talk about this down below. So the other problem that's interesting here is that you can take ethylene glycol, which is antifreeze, right? And ADH and ALDH forms this into oxalic acid, which is also poisonous. So too much of that can basically kill a person. Now, I've never tasted it. I don't suggest that you do, but antifreeze has a sweet flavor to it. So what happens is sometimes out in the garage, you get a hole in a bottle, it leaks, and the pet eats it, and then you have a problem, right? So there's a treatment to this, though. So how do we treat this type of situation? Well, what we need to do is we need to distract ADH so that we can just excrete the methanol, right, or the oxalic acid, or the ethylene glycol, before it gets metabolized to the oxalic acid. So let's just talk down below here real quickly at the treatment for methanol / ethylene glycol poisoning. So the idea here is that we want to do this. We want to slow down the metabolism of these two things, of ethanol and the glycol, right? We do that by introducing a chemical that competes with the methanol ethylene glycol metabolism. So there's two things that we can do. You can give ethanol, right? Or there's a new chemical, I don't think it's really that new, you can give something called fomepizole. All right, and both of these inhibit ADH. So the idea basically is like this, is here you have ADH, and ADH is like a giant Pac-Man, right? If you remember Pac-Man from back in the day. And it's got some things that it likes to eat. So it has ethanol, it'll metabolize that, it'll metabolize methanol, and it will metabolize ethylene glycol. So if you've consumed a bunch of this, then Pac-Man comes over and eats that up and makes a poison, right? It makes formaldehyde. Right? Now, if you introduce a bunch of ethanol, Pac-Man actually comes over here and says, well, I like ethanol much more, so it just stops metabolizing, right, the methanol, and it makes, right, acetic acid and acetaldehyde. But then it gives us time to excrete methanol. So we stop making formaldehyde by doing that. That's what this fomepizole thing here does too.